This will be a brief survey of noise, which improved, of two separate noise sources, followed by a judgment. I'll try to keep these going for about a minute. This is a summation of two sources. The average is running 0.18 RMS, and peaks to peak run about 1, as you can see, 1.1 volts. This is really just a way of confirming the two separate sources add algebraically. As you can see, sometimes you get a little over. Okay, that's about 1 minute of that one. Now I'll show you the basic circuit. Two separate circuits, a 1K and 1 meg for the big gain, and then a gain of 1K and 100K. These separate sources are identical. They're added through two 10K resistors, and you see the output, the oscilloscope. Power supply is very simple, 9 volts with division of two 10K resistors. There's the RMS of 0.11. So let's see, go back to this one. I will now do one source, the right source, and go back to 20 milliseconds. And 1/10 of a volt. Okay, to get best measurement, the peak to peak has to pretty much fill the screen. So this is the left one, or the bottom one. Notice how consistent the RMS is, 11, sometimes 10. The peak runs 66, 68, 74. The peak is about 6 times the RMS. That's a typical value. Occasionally you get in excess of 1 volt peak to peak. In any event, as typical. And the point it was to prove algebraic addition of noise with the goal of also showing the ensemble values. And I'll cover that later. Okay, and going to the other side, or the upside. This should be very close to the other, both of they should be almost identical, and they are at this point. Notice the occasional excess of, and I'll do it at 20 milliseconds, or 0.2 of a second per sweep. Again, the consistent 11, sometimes 12 RMS. Consistent 60, 70, sometimes you get excessive volt spikes, which is probability. When it exceeds about 1 volt, let's see if we can see that again. It's 9/10, so 9/10 of a volt, you're then in the red. and a very accurate value of 0.12, 0.11 RMS. 8.7 there is where you got the red. So this is a convenient documentation. I'm using the scope on battery, and everything is on battery to handle the noise. But what you really want is our consistent RMS. And the circuit itself is here. Show that very briefly. 2 large capacitors, resistors are shown, and then finally a summation circuit. So that's it. Very much a fun project and accurate.